Hey everyone. So today we'll be going over Insight 360. Uh, Insight 360 is Autodesk environmental performance software. It is under your Analyze tab, but you do have to download it. So you do have to go, just like you would any other plugin, and download it from Autodesk website. It's free to install, but it does require you have an Autodesk 360 account, which your educational licenses will cover. But when you do move into professional practice, it really depends on what kind of setup your firm has. So I have just opened up a generic model or a generic project file and imported our Kistefos Museum massing just to give you a little bit more dynamic of a idea of how the software works and the analysis that it can provide you. We'll go over this afternoon or whatever time you are watching this. We'll be going over lighting, solar, and then it has a full kind of analysis software that gives you not only the EUI, the EUI of a building, but also some things that you can do to the massing or your model or whatever that can optimize your building. It goes through some optimization. So EUI, I don't know if most of you are aware what EUI is, but that is the energy use intensity. Also, more simply, it is the energy that the building has to use per square foot or per square meter, whatever you're using. And it kind of shows the sustainability of the building. And there are some recommendations from ASHRAE as well as several different organizations on the targets a building should have for their EUI depending on the building type, so office, museum, warehouse, etc. And the Insight 360 provides an idea of that. So let's get started with some lighting. So I'm going to go under Analyze tab first just to show you where Insight is. It might be in the middle, but in ours it's on the far right. And this is the Insight with solar, lighting and solar, but it also encompasses this energy optimization tab. So it's really this whole tab right here. And for lighting, what we'll need is to produce some floors so that you can see the actual light, because what it does is it takes the lighting analysis a certain distance off the floor line, which is pretty typical in lighting analysis and daylighting analysis. And so to do that, let's create some mass floors. Level 1 and level 2, that's fine. All right, and then I'm going to associate some floors to those mass floors, floor by face, create floors. And then the other thing I'm going to do, because right now they're pretty much wide open, right? So what I'm going to do is create some walls, and I'm going to replicate the glass wall that turns into the ceiling by just leaving it open. So I am going to just quickly do a wall by face, metal panel, that's fine. I'm just gonna associate walls to, there we go, to where it is solid, and leave open where it is void. And of course, the more detailed you get, the more detailed the analysis gets. But for right now, we'll just do a basic analysis. So after we do that, before you start the lighting analysis or a solar analysis, what you want to do is make sure that your project is not only in the right location, but is also in the right orientation to your compass, your north, south, east, west. And so to do that, we've covered that before, but I'll just show you again. Location, you can change under location. Duh. All right, so location, want to make sure that the project that you're creating in Revit is actually in the right spot. So you can do one of two things. You can type in a zip code and search. Or not. Let's try Charlotte, North Carolina. There we go. And then it's going to give you the closest weather station to that spot that you can use the weather and the geographical location data from. So you hit OK. All right, then it changes the location. And then the one other thing you want to do is make sure that you're in the correct north, or it is, excuse me, the building's orientation is correct to your cardinal location. So to do that and to see quickly where your north, south, east, west is, if you go to a 3D view, it gives you the cardinal directions in your orthographic pan tool up here at the top right. You can also go into the project base point, which is that little guy right there, and you can change the angle. So I always suggest that you build your model as orthographic as possible, with as many 90-degree angles up, down, left, right as possible. It's much easier to model that way. Revit has a much easier time building your model if it's orthographic. And the only time you change the model to the actual true north is you use the project base point and you change it here. And you can change it to whatever degree it is. Excuse me. And then that will update the actual location. So if it did -30, let's say, it's going to switch north that way, etc., etc. And I think I've definitely covered this before, but if you are in a plan view and you want to change it from the project north, which is this orthographic view, to the true north, over on the right in your properties, you have a project north. You can change that to true north and it will rotate the project to true north. All right. So now that we have our model both in the correct location as well as in the correct orientation, we can use our lighting analysis. So if we go up to our Analyze tab up at the top and then go to Lighting under the Insight, click that. We're going to want to run a new analysis. So hit Go. And then it's going to bring up an Options tab. There we go. You can do a type if you need a specific type of analysis. Illuminance is what we're going for right now. You can also specify which level you want. There you go. So you can do all the levels or level 1 or 2. We're going to do all. And then date and time. So this is where you can specify how long or what day you want your analysis to do. So right now this is set up to be at the summer solstice from 9 a.m. to 3 p.m. I want to change that to 6 a.m. and I want to change this to 5 p.m. so we get a good full day of results. This, you can change the threshold for the upper and lower limits of lux or foot candles. Let's just do lux for right now. This is where that plane, so I told you that it takes it a certain distance above the finished floor line. This is where you can specify that. So 32 inches is pretty standard. You can do 4 feet if you want. You can do 5'4", which is around an average eye level, depending. And then resolution. So resolution, you can do a finer grid, which is a 12-inch grid, or you can do a 72-inch grid. And for both of these, it's asking you to check price. Now, check price is basically if you're a firm and you have a professional license, you get a certain amount of credits, and you have to buy credits to run this analysis. Since we have an educational license, we have unlimited credits. So you want to do the finest that you can do. 72-inch grid wouldn't cost anything, but the 12-inch would have cost 7 credits. So once you finish doing all of your settings and you have it the way you want, hit Start Analysis, and it's going to upload to the cloud, which is why you need an Autodesk 360 account to run these analysis, because all of the computing it does is done in the cloud. So don't close the project, obviously, until it is done uploading. It will tell you when it's done uploading. Just done. It's a pretty small file. It doesn't have a lot of detail in it, so it's going to be pretty quick. So press OK. All right. And then it's going to tell you when it's done. So right now, what we'll do is we will, while we're waiting for that, we'll start doing solar analysis. Now, we are doing a very basic model right now. I wanted to show you how it works, and that you can do these analyses and start to orient and think of your building in a more sustainable way from the very beginning, from the very start of a project, when you're first going through and doing conceptual massing, when you're starting to lay out a building. It's really key for you, especially if you want to focus on sustainability, that you run these analyses really, really early so you can start to make design decisions around them. So to do a solar analysis, and I'll show you later in the tutorial how you can use this for a fully detailed model as well. So let's go in. Here, let's do this. So I'm just going to go in. I'm going to hide. Let's fully hide these walls for right now, and I just want the mass and the floors. All right. So solar analysis, you can use just a basic conceptual mass, and I like to do this with a conceptual mass so you can see the greatest exposure that you're going to have, and you can start to manipulate the conceptual mass to be more sustainable and more adaptive to the position that you are in. You can start to orient the building in ways that are much better for solar exposure. So in the solar analysis, after you clicked solar, you can go in and hit, let's go here. So you can either do all roof exterior surfaces, which will select all the roofs, which is mainly what you're going to want to analyze. You can also do all mass faces, which we can do, or we can do a user selection. So what the user selection does is it lets you pick different faces. So first what I'm going to do is I'm just going to click all of the exterior mass faces. And once you're done selecting, you want to go over to the top left and hit finish. That will calculate the actual square meters or square feet of the faces that you've just selected. And then what I want to do is I want to go in and hit these little gear wheels for the settings. And you can go in, you can either do the current sun settings, which if we go down here, if we don't on here, we can change, we can do multi-day or we can do single day. I'm going to do the summer solstice. Make sure that it is from sunrise to sunset at every 30 minutes. Yes, hit OK. Update. Oh, I skipped ahead. But if you hit update, it'll run the analysis and start to visually show you the solar exposure. Before I wanted to do that, go back in to the sun settings, the little setting button right there. You can do that, and you can actually specify how fine of a grid you want the analysis to be. So you can get really fine. You can do up to like a foot and a half grid. That'll tell you how many points it will actually be taking analysis of. Of course, the finer you do, the more, the longer it's going to take to run. And especially on just a gradual face, very undetailed, you don't really need that fine of a grid to get a good analysis. So hit apply. Oh, and our illuminance test is done. So we're going to accept, update, and save the project. And then the last little bit of settings that you can control down here is if you hit this little arrow button at the bottom, it'll drop down here. You can change the type of energy output you want to have. You can do the cumulative insolation, which is the average over the whole day, or the total over the whole day. You can do average, which takes obviously the average of the day. And then you can do peak, which is the highest intensity it has. Let's just do cumulative, so you see the entire day's factor. And then you can do different styles. So styles, if you hit the dot, dot, dot at the right, you can actually go in. Make sure that you have the same style selected on this window that you do here. So solar analysis default, we want to make sure that's selected. And then you can go in and manipulate the visual aesthetic that it creates. So you can change the color. I just do pretty simple green, yellow, red, but you can do ranges. You can do wide range of different degrees. You can see if you select different styles, they have different color settings. You can also do grid lines. So this will show you that coarse to fine grid. If you do a really, really tight grid, it'll show a really, really tight grid on your actual mass. I'll have that selected just to show you what that is. You can also turn on transparency, so you can have the heat map that is selected on your face to have some sort of transparency. So if we hit OK, hit update, now you can see not only does the mass have a little bit of transparency so you can see the floors below, but it also shows you that point grid. Now if we went into the settings and we increased, yeah, there we go, we increased the grid, we hit update, it's going to have a much finer grid than if we did a course. You can see how much those have grown. And then with the heat map that it provides, it also gives you a little legend to show you the actual values that those color ranges are visualizing for you. So if we go in, go back to style, and then we turn off the grid lines and turn this to 0% transparency. There we go. We can see that in this specific orientation, obviously the top of our building is going to have the most solar exposure. That is common in every single project. And then we have solar exposure on this twist here as well as this twist here, and then pretty green on the majority of sides, which is good. And I bet if we updated our face, actually let's just do all mass faces, hit update. Yeah, we can see that we have some more solar exposure on this north face, and we could potentially get it really green on the longer faces and yellow on the shorter faces if we rotated this to a true east-west. So if east was over here, west was over here, vice versa. Okay, so we can show that. What do we do with it? Well, you can show the reviewers or your client, etc., that specific orientations work best with the mass that you have. To reduce the amount of solar exposure on the face of the building. You can also use this to identify different faces for shading, better areas of the facade of the mass for glazing, right? So I'm pretty sure this is a more northernly exposed face, which is why it is so green. We would typically want to identify the majority of our glass on this face because it has the least amount of solar exposure. And maybe if we wanted to have glazing, running up this wall and onto the ceiling, since it does have significant amount of solar exposure on the top roof, and when it twists, maybe we identify some shading devices on that roof to reduce the amount of solar exposure onto the glazing while still getting the benefit of natural daylight. Okay. One other thing you can do with this analysis tool is you can actually export a Excel spreadsheet that has the different types, or excuse me, the different readings for each one of those grid points. Which you can specify here. CSV is essentially a Excel spreadsheet, and if you hit export, it'll ask you where you want to specify. You can say wherever. So analysis example, I've already saved one, and if you open it up, what it's going to show is it's going to show the three or the different instances that you had. So in this specific analysis, I had 4 walls selected. They were 4 mass walls, and then it has an identifying number for each one of those walls, and those identifying numbers correlate to these different surfaces. So 964 is this family right here, and then for each one of those points, it gives a value. So each one of these readings is a specific point. It gives the X, Y, Z, and the normal for that point in relation to both the Revit environment and the surface that it lies on, as well as the actual value, the exposure value, that insulation value for each one of those points. And you could use this information specifically if you're creating let's say a parametric shading device, right? And you have a really dynamic facade and you want to control, the angle of the shading device or the opening of the shading device comparatively to each one of these points. You can do that. Potentially you could, just like we've done in the past, import this into a Grasshopper script, attribute each one of these insulation values and redistribute them to a certain opening percentage or a certain angle percentage, and get a really, really dynamic as well as a really, really performative shading device. And that can be attributed to a bunch of different things. So that is solar. There we go. So now that our lighting analysis is done, we can go in to so it will create a specific 3D view called Insight Lighting Model View. And then to bring up the lighting analysis itself, you just have to go back into the lighting under Insight, and then instead of running a new analysis, if you hit this drop down, it will show you all the different lighting analysis that you've done in this specific project. So I've obviously done a bunch. You want to select the most recent, which is this one right here. And all you gotta do is hit go, and it will bring up that analysis. All right. shows you some data for the results, and then it shows you this graphic. So once again, just like the solar analysis, it gives you a set of legends that show the values for each of these different performance analysis. It also has created lighting plan views in the past. But if it doesn't do that, there is a thing that we can do that I haven't shown you yet. So we can actually create a orthographic 3D view. If we go to an elevation or say a section, if we go to our view, hit 3D view, camera. Now, typically this would create a perspective 3D view, but if we go to the top left and we uncheck perspective, what you can do is take the camera from a certain distance above the floor line and then draw the line completely perpendicular to the floor. What it does is it actually creates a 3D view, but of the floor. And then if we go analyze lighting, there we go. So it will give us a plan view of that 3D view. So this is our top floor. So you can see that we have a lot of solar exposure from this open face here, as well as from the open face at the top. Sorry. From the open face at the top. And then if we do another one, we'll call this level 2. If we do another one from the first level, so do a camera, uncheck perspective. And then do another pull-up bar now. There we go. So this is a pretty dynamic one. So this is our level 1. Oh. Make sure you actually hit it. Level 1. So we have a lot of solar exposure from the open ends here, as well as the open ends on the left, and we have an open face here. But we're pretty good here. Now, problem is, of course, you want daylighting into as much of the space as possible. You just don't want direct solar exposure. So that's why you want to have a lot of those northern faces open so you get a lot of diffused daylight. So realistically, we would want this face, which is open, to be northern facing, which based on our solar orientation that we checked, it still is. Right. So this has been Insight 360 for the conceptual massing environment, really doing some quick studies when you're really early into the process. Oh, sorry, one more thing. Sorry. So to just delete that solar analysis, all you got to do is select and delete. And then the last thing you can do to get that overall energy performance analysis is under this energy optimization. And this is where it looks at your model and then makes recommendations to potentially optimize it for a more performative building. So this is going to take this 3D view and it's going to generate a model based on some settings. So if we go up to energy settings at the top, so since we really only have conceptual masses, but we also have some floors in there, so we'll want to do conceptual masses and building elements. And then this is the resolution of the space. So this is at 1'6". Let's make it 1 foot. New construction ground plane is going to be at level 1. Yep. And then if we go to other options, sometimes you can specify the percentage glazing, but down here, this is the big one. So this is where you specify the building type, and it has pretty much every different type of building you can have. And the reason for that is, like I said before, each building type has a target EUI that you want to try and hit based on the use of the building. So, you know, a museum is probably going to have a lower energy performance than, let's say, or not a warehouse, but it's not a fabrication. Is it under here? Like, okay, manufacturing, right? Because manufacturing is going to have a lot of large machines that are running 24/7 typically, and they use a lot of electricity, right? So museum's going to have a lower EUI target than that. You can also specify how open it's going to be, so whether it's going to be running 24/7, 24/5. Typically museums maybe are open for 12 hours a day, sometimes 7 days a week, sometimes 6. And then also you can specify different times. So like worship is going to be once or twice a week. Year-round schools are only going to be for 9 months out of the year typically. So, and then you can specify different MEP systems, mechanical systems. Some of you may know what these mean, some of you might not. This is really going to be based around what your client is asking for, especially their price point, and going to have recommendations from your mechanical engineer on what exactly we can use to provide to meet those standards that your client wants. Outdoor information, this is how much fresh air you can bring in per person or per square foot, depending on what you want to do. And then, also air changes per hour. So this is asking how much of the building you want to have changed. So I think for healthcare, it's pretty frequent. So like if we change this to 1, that's going to mean that the entire amount of, or the entire volume of air within the building is going to be completely changed out with fresh filtered air every hour. So it doesn't necessarily matter for us here. Let's just keep it to 15 CFM. And then especially when you're doing conceptual massing analysis, what it's going to do is it's going to say, top one is a roof, sides are walls, and then mass floors are a specific type. And this is where you can specify the exact, or not exact, excuse me, but a general type of wall, roof, building element that you want. And each one of these has specific insulation types along with it, right? So you can have a really high insulation exterior wall for the floors. Typically floors don't have a lot of insulation unless a floor is exposed to the elements or isn't conditioned, and then you'll want to insulate that from the floor above or below. Type of glazing, so you can do really, really high quad pane, low E glass if you want. Skylight, same thing. But here you can specify if you want to make it really, really sustainable or if you have a more economical building. Specify that. Press OK. And then press OK. And then once you create those settings, you can create the energy model. That's OK. Create the energy model. Bump, bump, bump. And then what you can do is generate a series of optimizations, and this takes this model and brings it up to the cloud and runs a series of analysis on it based on different orientations, based on different types of building elements, types of shading elements, etc., and then it will give you an output. And since I've already done this, we don't have to wait. I already ran this. So if you hit this button up here, optimize, that's going to bring you to the website Insight. which has all of your different models that you run. There we go. If you hit optimize, it'll bring you to the website. And then you can see that it brings in the model. It analyzes different surfaces. So I believe what it does, so the orange is floors, the green is walls, and the blue is roof. So that's what it's analyzing, is roof, walls, and floors. Since it is a conceptual mass, it has to make those assumptions. And then down here, this gives you all the different optimizations it can do, right? And this also gives you ASHRAE's target. So this is what you actually have to hit if you're trying to meet ASHRAE 90. And right now we're on how much money it's going to cost per square foot per year. If we go in and click this button up here, it's going to change to the EUI, which is the amount of energy it outputs per year per square foot. ASHRAE is 124. The 2030 target is actually 17, so it's pretty significant. And right now, as a base, we are at 183. So if we go to a couple different settings, so this is where we can see how we can optimize the building based on its orientation. So down here, it has different degrees. So right now, this is where we have modeled it. And then if we go 90 degrees, it'll lower it by 0.43. If we rotate it the other way, 45 degrees, it'll go down -1. It's not a significant amount of savings, but it still could be some if you're trying to get the most optimal orientation. And then it shows different types of building, right? So if we do triple low E glass, can save 11 kilobytes, kilowatts, no, kilobit, I don't know, 11 units of energy per square foot per year. Let's go, we can do shades. So if we have a significant amount of shades that are 2/3 the window height, it can save 9 kilobytes, kilobytes, energy units per square foot per year. Same thing, wall construction, if we have a significant, so this is where it really starts to give some savings. If you have a significant amount of, so if you're uninsulated, if your walls are uninsulated, it will raise this EUI by 34.9, but if you use some really good insulation, it can reduce it by 10. Let's see, infiltration. So one of the biggest things, we just did a net zero school down in Orlando, and the biggest item for making sure that that building was as performative and as sustainable as possible was making sure that that building was as airtight as possible. So right now, if you let out 2 ACEHs, which I don't know exactly what that unit is, but if you let out a significant amount of the air, you're essentially having to recondition that space a lot. So you're going to be using a lot of energy reheating or recooling that air. If you make it super airtight, you can reduce the amount because it maintains and retains that conditioned air as much as possible. We did a lot of infiltration tests where they would go around and test all the different gaps for air leakage. Plug load, PV, panel efficiency. So if you get super performant, 20% efficient PV panels, you can reduce it by almost 8. If you cover 90% of the roof with PVs, you can reduce it by 15, right? So all of these add up. You can reduce significantly by if you use a high efficiency mechanical units. If you use a high efficiency heat pump, you can reduce it by -30. That's a huge savings. So all these add up. If you do all of the most sustainable things, you can probably reduce this just as a baseline down below the ASHRAE recommendation. Now, this we did all this for conceptual massing. Now, if we go in, close this out, we can actually open up a fully detailed model to show what that may look like. So I've shown you some sample projects before, but every Revit has fully detailed sample projects that you can open and look at, test out. And they're found under your computer. If you go to the C drive, then go to Program Files, Autodesk, go to scroll down to find the Revit version that you're using currently, and then go down to Samples. Has all the different sample projects. And then you can do Advanced Sample Project Revit. Make sure it's the project, not the family. Hit Open. All right, so it's a fully detailed model. And we can do the same type of analysis on this model that you did before. So if we go to Analyze, go to Solar, now we can select, we want to select these because obviously there's a significant amount of surfaces, and we don't want to select all the roof faces. We want to select these ourselves. So if we do user selection, yeah, that's fine. Let me change this to wireframe and select some of the larger. Okay, so these are the larger exposed faces, and we could also do some floors. Oops. Sorry about that. Let me redo this real quick. Hit finish, update. And for these more detailed models, they are going to take longer. But right now, it's not bad. Let's see. So this face has a lot of, maybe a lot of exposure. So you can use the solar analysis in the same exact way. You can also do lighting analysis. So you can do your lighting, run new analysis. And let's just do the second floor. All right, model's uploading. This might take a little bit. One thing with the solar analysis you can do the same thing that we did with the conceptual mass, where we took the orthographic perspective, which isn't really perspective, and we just shoot this directly down. That's fine. So now we have a 3D view almost. And if we go back to our analyze, do solar, Then we do the user selection again. And just click the floor itself. Hit finish. And then hit update. So we can identify areas where we have higher direct solar radiation than others, right? So, for example, we're having a pretty high solar exposure on this far corner. What we could do is either we could go back in, put some solar shading on there to reduce the amount of direct exposure it has, or we could just make this completely solid wall to reduce that. And then the other thing we can do, same as we did before, is we can create energy model from this guy right here. I've already done it since it is a pretty big file, but same thing, you can control the settings. Of course, with this one, you're just going to want to use building elements, not conceptual massing. Same kind of options that you had before. Of course, make sure that it's the correct building type. And then go to optimize, which will bring up the website again. And then if you go back, oh, one thing to remember as well, sometimes if you are just starting out, it will default to metric. It will give you per square meter instead of per square foot. Just want to change that. You can also change the type of currency, if you're in Europe or in Australia, whatever. You can also do, I think that's just the primary thing. Oh, it didn't look like it updated. Darn. Well, I can show you one anyway. This is a different sample project that I ran. Just like before, it's identifying walls, floors, etc. And then it gives you the same type of optimization options down below. All right. So it takes you a really detailed model, makes it pretty basic. And then gives you a reading based on that. Now, of course, this isn't super detailed, and I don't believe it would be able to be used by in specific code. But it's good to get a general overview of how sustainable your building is, how performative it is, and to make really smart, sustainable design choices as you're going through and designing your building. Okay. All right. So this has been Insight. If you guys have any questions, let me know. Talk to you later.